All right, we are officially live. Welcome, welcome everybody on in. I am Robert EAP Math Guy, and tonight we're going to talk about L'Hopital's rule. So as you are joining in, go ahead and let's do a mad tap to get this live started. Yeah. So again, How's everyone's Tuesday night? Let me. For some reason, I'm not sure if you can hear me or not. Can you hear me? Okay. Or am I like? Or do I sound like I'm 6 miles away from my microphone? Hopefully people can hear me. But yeah, so I'm gonna go ahead and wave and click the button that allows me to wave at people. But if not, if I can't click on that button and you're here, I'm gonna go ahead and wave to you here. Hi everyone. Calc 3 L'Hopital. Nope. We're gonna deal with Calc 1 L'Hopital's rule. But I am planning on doing Calc 3 probably in the next couple of months. I'm not sure yet. So here is a list of everything that we are going to be doing from now until Sunday. So last night we did linear approximation, so I'll put a check mark there. And I've already downloaded that. And uploaded it. I've already uploaded it here. So this channel specifically is where all my lives are going to be once they're done. I've been lucky to get them up within like an hour, but I know that sometimes that's not going to be the case. So, but I will have them up as quickly as possible after they're done. So tonight's live will probably end up there sometime in the next few hours or so, but I'm not sure yet. But yeah, so hopefully everyone's having a great Tuesday evening. I know I am. I got a late start today, so that's always fun. I must have been really tired or something. But yeah, so I'm going to spend the next couple of minutes just waving at people by clicking the button. Hopefully, yeah. There we go. So we are almost done Calc 1. We are going to be moving on to Calc 2 sometime probably in the next 2 weeks. Yeah. As I wave to everyone, hello everyone for joining in. Welcome, welcome on in. How to do limits where if you plug in the limit it gets 0 over 0 or infinity. Oh! Awesome! Thank you for the crown air. Thank you so much for the crown. Thank you so much. That's awesome. But yeah, back to your question, Sammy. How to do limits where if you plug in the limit it gets 0 over 0 or infinity over infinity? Well, this is a way that we can do those limits. There are other ways to do it, but tonight we're just going to use L'Hopital's rule. It seems like any time I do lives, when it involves limits, they always say, "Oh, you could do L'Hopital's rule," and for the most part, it's true. But there are certain conditions that have to be met with that. Keep up the good work. I'm currently taking Calc 1, and you've been. Thank you, Air. Thank you so much. I really appreciate that. Thank you so much. So yeah, it just takes a quick sip of water, and then we'll get started. There we go. If there's one thing I've learned since starting to go live here on TikTok, it's that you need to have water right near you. Otherwise, the throat gets really dry and you start to sound like you're gasping for air. And we don't want that. Alright, so let's go ahead and get started with tonight's work. So, L'Hopital's rule. So, suppose I want to find the limit as x approaches 0 of two different functions. Let me just click. Thank you, Gian, for sharing the live. There we go. The one thing about touchpads is that sometimes they don't do a very good job of knowing when I want to left click or right click. So let's say I have the limit as x approaches not. Actually, it doesn't have to be 0. It can be any number. Let's let it be a. And of f of x over g of x. And by plugging in a, it results in 0 over 0 or infinity over infinity. Yo, can you cover implicit differentiation after this? I was absent when my class covered it. Okay, Little Wayne. So I actually already did a full live on implicit differentiation, and you can find it here. I have a full live dedicated to implicit differentiation that I just posted on my channel not too long ago. Hey Lisa, how's it going? Who's Mike? Who's Joe? Yeah, no problem. If you need to take a screenshot of it, let me know. Have I done any series tests yet? Not yet. Series test is going to come for Algebra 2. And, I mean, not Algebra 2. Calculus 2, and we're not quite there yet. Great, I'm sorry, what is your... No problem, Lisa, my name is Robert. Hi, Robert, sorry for missing your name, I'm glad to be in your class. No problem, Lisa. No problem at all. Hey, Joe and Mike are not the worst things I've ever been called. Have you done... Oh, why does L'Hopital's rule work? I'm glad you asked that, yo. I'm going to actually get into that in just a moment. But basically, yeah, if you keep taking the derivatives, you'll eventually get to a constant. Right. So I was actually just going to explain that here in a moment. Well, I remember back in Calc 1, they didn't let us use this rule in tests. Yeah, so really, this is, say, when you first learn limits, we don't know the idea of derivatives yet. So we can't really apply this to if we don't know about it. But once you get towards the end of AP Calc 1. Then you get to the point where you can do this. Can you apply L'Hopital's rule to any equation that equals 0/0? So it really depends on. So L'Hopital's requires this thing called a limit. So if I have say limit as x approaches any number of f of x over g of x, and the result causes division by 0 or not division by 0, indeterminate form, then you can use L'Hopital's. All right. That's a that. Hey, if that helps, Mitz, but it's actually there's no S in L'Hopital. Thank you, Frog, for sharing the live. I remember nightmares congruent to L'Hopital's rule. Okay, I'm sorry you had those nightmares. I need help with physics. Do you do that at all? It has been a really long time since I've done physics. I'm sure if I could go back and remember it, um, then yeah, I'm sure I could, but I've forgotten a lot of the physics. That said, I did say that I was going to relearn physics, and I'm about to start that process. So, what topics do I cover? So, I cover anything that I tutor, which is anything in these subjects. And actually, let me zoom out quickly. L'Hopital was so fun. Limits in general are fun. I agree. They can be a little bit of a headache sometimes, but yeah, I agree they can be fun. Thank you, Lisa, for the 5 roses. Please give a summary of what you'll be teaching the topic, please, tonight. So we're going to be talking about L'Hopital's rule. So, if I have this happening, then we can use what's called L'Hopital's rule. And thank you, Air, for the follow. So, then we can say that the limit of that function would equal the limit as x approaches the same number of the derivative of the top divided by the derivative of the bottom. Do I teach AP Pre-Calc? I do. I do indeed. AP Pre-Calc's relatively new, though. There we go. First water done. Okay. So we're going to apply this rule tonight. I take linear next semester. When do you think you'll be covering linear? Linear algebra? I would have to really look in my calendar. I think the answer to that question would be it'll be sometime next year. Like next calendar year. So the plan is I'm starting Calculus 2 in October. I have to look through and see how long that's going to take. Then I'm going to Calc 3, see how long that takes. Then I'm probably doing differential equations after that, and then linear algebra after that. So if I had to guess, and again, this is just a guess, if it takes me about, I'm going to say, let's say it takes me doing live every day, let's say it takes me a month and a half to get through Calc 2. So that would put me, middle of November. Then Calc 3, I'm going to say a month and a half as well. So that's January, early January. Month and a half for differential equations would put me about mid-February for that. But again, that's just a guesstimate. Differential equations is what I'm doing right now. Okay, how's it going? I should have stacked diff with linear, but my physics class clashed with it. Yeah, no, I don't recommend. I wouldn't recommend that you take differential equations and linear algebra at the same time. Again, that's just me. Um, I had a student once who took differential equations and calculus 3 at the same time. They ended up failing differential equations. Hey, love, how's it going? And you'll need to apply rules inside of rules. Oh, you're talking to Alexander. Okay, cool. No, the flashbacks, not linear algebra. I hated that. Okay, I'm sorry. I'm sorry to hear that, La Latina. Um, like that. Don't worry. We're not gonna be there probably for another few months. Okay, so let's try a few different exercises in which we can use this rule. And it turns out that so long, if the first derivative still gives me this or this, I can take the second derivative and I can do that over and over and over again until one of two things happens. Either A, I get an answer, or B, well, I guess one of three things. Either A, I get an answer, B, I can't take the derivative anymore, or C, um, well, I guess those are really the two cases, aren't they? All right, I got my iPad and pencil ready for notes. Awesome, Lisa. Glad to hear that. I get the rules and everything, but I still get stuck. Okay, well, don't worry, because I have a list here, and we will probably be using several of the rules tonight. Thank you, VBall USA, for the follow. I'm using you to pass my calc test. Hey, if it works, right? Oh, thank you for the 5 more roses, Lisa, and thank you, Math Tutor, for the heart me. Hey, Math Tutor, how's it going? Okay, so let's stop stalling and let's get started. So, for my first question is going to be the following. So, I have the limit as x approaches 2 of the following. So I have x cubed minus 7x squared plus 10x all over x squared plus x minus 6. You're welcome, things are going well. I'm glad to hear that. I'm really glad to hear that. So, now, let's go ahead and find the limit as x approaches 2 of this function. Thank you, Frog, for sharing the live. Is this 12th grade math? So, at this point, this is calculus. So people do take calculus in their senior year of high school. I did. But people also take people also take it sooner, and people also take it in college. So at this point, it isn't. I wouldn't associate it with any particular grade level per se. So the first question answer is just with derivative. So the first question answer is just with the derivatives, and that's it. Are you talking about this? Okay, so this is the rule. So this is I probably should have labeled it, but this is L'Hopital's rule. There we go. They teach it in 3rd grade? Really? That's interesting. That is really interesting. For your eyes only says factor. I could. I could do that. But the thing is it worth it to do that? Well, first, let's see if we're even able to do L'Hopital's rule. So my first step, when I have a limit problem, is to always plug in and see if I need to do anything further. So, if If I plug in 2, I get 2 cubed minus 7 times 2 squared plus 10 times 2 all over 2 squared plus 2 minus 6. Thank you, Ian, for the follow. So I have 2 cubed. 2 cubed is going to be 8. 8. 2 squared is 14. 14 times... No, yeah, 14. Good job, Robert. Let's try that again. 2 squared is not 14. It is 4. And 4 times 7 is negative 28. There we go. And then 10 times 2 is 20. And then I have 2 squared is 4 plus 2 minus 6. So here, I have 8 minus 28 is negative 20. And negative 20 plus 20 is 0. And then I have 4 plus 2, which is 6. 6 minus 6 is also 0. Well, 0 over 0 is not 0. This is indeterminate. So what can we do? Well, we can use L'Hopital's rule. So let's go ahead and do that. So here, I'm going to need to use the power rule. So what I'm going to do is I need to familiarize myself with the power rule. What does the power rule say? The power rule says if I have a variable raised to a power, its derivative is solved by taking the exponent, moving it out front, and multiplying it by whatever coefficient's in front, and then subtracting 1 from the exponent. So, thank you, Jack Daniel, for the follow. So here, I have limit as x approaches 2, the derivative of x cubed. So here, I take my 3, move it out front. 3 times 1 is 1. So that's going to be 3x to the 3 minus 1, which is 2. And then I'm going to move over to this next term. Why? Because if I'm adding or subtracting two things together, the derivative is going to be the derivative of the first plus or minus the derivative of the second. And this goes on forever. So if I had like 8 different functions that I was adding or subtracting, then it would be the derivative of those 8 things being added or subtracted. So here I have 7x squared. So I take my exponent, move it out front. Negative 7 times 2 gives me negative 14. And then I have x to the 2 minus 1. 2 minus 1 is 1. And remember, a variable without an exponent is the same as that variable raised to the first power. So I'm not going to write a 1 there. And then I'm going to use that same thing here. So remember, variable without exponent is variable to the first. So I have 10 times 1 is 10. And then I have x to the 1 minus 1. So 1 minus 1 is 0. And remember that x to the 0 is equal to 1. So this is 10 times 1. And 10 times 1 is 10, so I'm going to leave it as like that. Now we move on to the bottom. What would be the derivative of this bottom function? What do you think? What would be the derivative of that bottom function? Hey Z, how's it going? You say 2x plus 1. Alexa says 2x. BC Dishman says 2x plus 1. Smiley Face says x. Ness says 2x plus 1. My calc teacher doesn't let me use L'Hopital rule. Okay. Have you learned about derivatives yet in class? Thank you, Alexa, for the follow. Yeah, so it's going to be 2x plus 1. Very good, everyone. Thank you, Tro, for the follow. And now, I only got to squeeze theorem and intro to limit, so I'm trying to get ahead now. Okay, well, I have a few lives that I don't know if you were here at the beginning, but I have a few lives that I have posted already. and you can find them all here. And this one will also be there. Do I teach Calc 2 and 3? I do indeed. Yes, we had to solve. Yes, we just had to solve it not using L'Hopital's rule. Okay. Yeah, if your teacher says to solve it a certain way, solve it that way. Thank you, BC Dishman, for the love you so much. Thank you so much. And thank you, Lenny, for the follow. All right. Are we taking the derivative disrespect to x? Yeah. So we are taking the derivative with respect to x. What conditions need to be met before you can apply L'Hopital again? So L'Hopital's rule takes effect if the limit of a function divided by another function results in either 0 over 0 or infinity over infinity. Thank you, Z, for the follow. All right, so now I have this, and what I can do now is let's see if I can use L'Hopital's rule. Or let's see if I need to use L'Hopital's rule again, rather. So I'm going to plug in 2 everywhere I see an x. So this is going to be 3 times 2 squared minus 14 times 2 plus 10. And that's going to be all over 2 times 2 plus 1. So 2 squared is going to give me 4. And 4 times 3 is 12. Excuse me. And then negative 14 times 2 is negative 28. And that's going to be plus 10. And then here, I have 2 times 2 is 4. 4 plus 1. If this is the case, what would this equal? What would be the answer to this question? What do we think? Is L'Hopital's rule taught towards the last material covered? So it's usually covered as one of the last topics of the first half of AP Calculus. So when you start to move on to when you start to get ready towards anti-differentiation, you're going to learn about L'Hopital's, but it's going to be like it's like it is towards the end of the first semester. BC Dishman says negative 6 over 5. Moxall says negative 6. J Rogue says negative 6 over 5. Alexander says negative 6 over 5. All right. So let's see if you're all right. So 12 minus 28 gives me negative 16. Negative 16 plus 10 gives me negative 6. And then 4 plus 1 gives me 5. So that is our answer. Very good. Very good indeed, everyone. Indeed, it is cool, Alex. Any questions so far? Can you do one with chain rule? Yeah, I have one prepped with chain rule, but I wanna get people eased in before we do harder ones. BC, thank you, BC Dishman, for the follow. Can this be done if there's a radical in numerator or denominator? Yep. Yeah, I think so. I don't see why not. Thank you, Dale, for the follow. What happens if it's 0 over 0? So, are you talking about after we do the first derivative? If we still get 0 over 0? Yeah. So if after doing this we still get 0 over 0, because I don't have because I don't have 0, I can take the second derivative and I can do that again. So I can actually do L'Hopital's rule as many times as I can do, and as long as I'm able to. So if I have, like, I don't know, let's say I had something like take the second derivative of that would be 2, and after a third derivative, because this denominator would be 0, I can't take the derivative of that anymore. So once I get to a point where I no longer can take a derivative, if I still end up with indeterminate form, then it does not exist. I don't think we're going to run into any of those tonight, but we'll see. Yeah, no problem. But yeah, so I do have some chain rule on here. In fact, it's funny that you mention it because I think our next one is going to have some chain rule in it. All right, so I'm going to separate this problem from the rest. There we go. Okay, so now let's find the limit as x approaches -4 of the following. So I have sine of pi x over x squared minus 16. When do you need this rule? Sure, so we use it when the limit as x approaches a of a function divided by another function gives us either 0 over 0 or infinity over infinity. Now also the other thing we have to recognize too is that we can only use this rule so long as our result gives us indeterminate form. If this were, let's say up here, let's say instead of 0 over 0, I had 3 over 0. If I have 3 over 0, then I cannot use L'Hopital's rule. So it's very important to know when to use it. Thank you, War, for sharing the live. And hey, Brandsy, how's it going? All right, so let's go ahead and plug in -4 and see what happens. So I have sine of -4 pi over -4 all squared minus 16. So let's go ahead and figure out what that is. Thank you, user, for sharing the live, and thank you, our CC, for the follow. So let's go ahead and revisit our unit circle. So I have sine of -4 pi. So remember, the sine is the y value, the y coordinate. And because I have negative... That's right, Jay. That's absolutely right. That's absolutely right, Robin. Thank you, Lucy's, for sharing. So, and thank you, Epsilon, for sharing the live. So here, because I have a negative inside, that tells me that I'm going to go not counterclockwise, because we only go counterclockwise when it's positive, but we go clockwise when it's negative. So this number tells me, we're not looking at the degrees, we're looking at this number here, which is called radians. So we're looking at, so this tells us how far we've traveled along the unit circle. So one full revolution of the unit circle is 2 pi radians. And I have to travel -4 pi radians. So that means I need to travel counterclockwise until I hit -4 pi radians. So let's go ahead and do that. So I'm going to go ahead and travel along the unit circle. My pen is traveling. We're all going on the Ferris wheel or the merry-go-round or whatever. So I'm traveling, and I get to 2 pi. So I've done one full revolution, and I've only gone -2 pi radians, so we have to go again. So we're going to go another spin on the unit circle until I get to 4 pi. So I'm going to travel. Here is -3 pi. So I'm going to travel some more. Traveling along the unit circle. And then, now I'm here. I've done 2 revolutions clockwise. So this is going to be where -4 pi is, right? Why? Because we said that one full revolution is 2 pi. And since we're going in clockwise, this is -2 pi. So if I do 2 revolutions of 2 pi each, then that's going to be -4 pi. So what's my y value at this point here? Thank you, Weasel, for the follow, and thank you, Nahar, for the follow. Yeah, I know, right? This is so. This is why I keep my unit circle. Man, I just had a test on this stuff. Okay, how do you think you did? Wait, can you go over epsilon and delta proofs or after? Actually, I've already done a live on epsilon delta that you can find here on this channel. Jay says 0. Lisa says 0. User says 0. Yeah. So remember, sine is the y coordinate. So sine of negative 4 pi is equal to 0. And then I have negative 4 all squared is going to be 16. Because remember, I'm squaring the negative as well. So negative 4 all squared is 16. And 16 minus 16 is 0. So I have 0 over 0. Can I use L'Hopital's rule? Yes, I can. So what I'm going to do is I'm going to take the derivative of both the top and the bottom. So let me go ahead and do that. Now, first question. Does anyone know what the derivative of sine of pi x is? Okay, Jake. That's a fine answer. Cosine x, pi, cosine something. So Air and Joey, combine your two answers. We do have to consider the pi, right? Almost, Griffin. You almost got it. Almost, user. You're missing something. That's right, Robin. That's absolutely right. So why is that right? So let's pretend for a moment that instead of taking the sine of pi x, I'm going to take the sine of my bottle cap. So I want to know, what is the derivative of sine of bottle cap? Well, the derivative of sine of bottle cap is going to be cosine of bottle cap. Oh, here it is. So here, if I look here, let me move it up here. So if I look here, I have d dx, so that tells me take the derivative with respect to x of sine of x. That gives me cosine of x. So this is going to be cosine of whatever's underneath my bottle cap. What's underneath the bottle cap? It's pi times x. This is going to be pi times x. And now that I've revealed what's underneath the bottle cap, I now need to take the derivative of that. So remember here, I'm going to use power rule. And what does power rule say? Well, power rule, remember, says take the exponent, move it out front, and subtract 1 from the exponent. And here, I have x without an exponent, so that means we can assume that the exponent is 1. So I have 1 times pi is pi times x to the 1 minus 1. And remember, x to the 0 is equal to 1. So the derivative of pi x is just simply pi. Thank you, Chava, and thank you, Shirley, for the follows. I thought pi is a constant unless we're multiplying it. No, pi is always a constant. Pi is always a constant. And then, what would be the derivative of x squared minus 16? Griffin says 2x minus 0. Picasso says 2x. Bone says 2x. Christopher says 2x. Robin says 2x. Yeah. So it looks like we have an agreement. Take the derivative, take the exponent, move it out front. So that's going to be 2. X to the 2 minus 1 is 1. And then the derivative of 16, well, remember 16 is a constant. And how do I know it's a constant? I know it's a constant because there's no variable next to it. So the derivative of a constant is always 0. So now I have pi times cosine of pi x all over 2x. So now let's go ahead and plug in negative 4 and see what we get. So I have pi times cosine of pi x all over, oh, this should be 4, negative 4, all over 2 times negative 4. So remember that negative 4 pi, if I go to my unit circle, here, negative 4 pi means I go 2 revolutions around the unit circle clockwise, because clockwise tells me negative and counterclockwise is positive. What is this? This is L'Hopital's rule. And for the subject, this is calculus. I actually already did a live on squeeze theorem, Connor. You can find it here. So yeah, thank you, Emma, for the follow. So what I'm going to do is I'm going to go 2 revolutions around the unit circle clockwise. So if I go around the unit circle twice, so there's 1 revolution, and there is the second revolution. So I'm at negative 4 pi. My mic is cutting out a little bit. Okay. Thank you for letting me know. Is that better? Sounds is okay. Cool. Awesome. Can you explain, could you explain why a derivative of pi x is pi? I thought a constant derivative is 0. That's right. So it's the same reason as why the derivative. So actually, let me answer this question quickly, and then I will go back to that. So Air, if you could, when I'm done this, retype in that question, because I do want to answer that. Thank you, Aziz, for the follow. So, where was I? Oh yeah, so here is negative 4 pi. And on the unit circle, with y value is sine, and the x value is cosine. So, cosine of negative 4 pi is the x value here. So what would cosine of negative 4 pi be? Thank you, Abu Bakery, for the follow. Right, Picasso, it will be 1. Right, Bones, it will be 1. Right, Connor. So here, I have cosine of negative 4 pi is 1. 1 times pi is pi. And then negative 4 times 2 gives me 8. So my answer is pi over 8. Any questions on that one? Oh, right. Air, your question. So, let me go ahead and quickly explain why the derivative of... Okay, Lisa, have a great night. Thank you for joining us. And thank you for the 3 more roses. Should it be... You're right, it should be negative. You're absolutely right. Thank you for catching that. Okay, so, Jason, joining late and just started this in class, so we check for 0 over 0, and then we take derivative, and that's it. Yep. Yep, that's it. Could you use trig identities to also solve this? You could. But sometimes L'Hopital's rule is easier to use. And like I said, we can use L'Hopital's rule so long as we have 0 over 0. Or infinity over infinity. If we don't, then we can't use L'Hopital, and we have to use another way to solve it. Or we say it doesn't exist if we can't find a way. Alright. Air, your question about pi x, I haven't forgotten. So, it's the same reason why the derivative, so d dx of pi x is equal to pi. The same way as the derivative of 8x is equal to 8. Why? The reason why is because the derivative tells the story of the slope. And when I have pi times x, that's a linear function. and the slope of a linear function is always this constant in front of the x. So whether it's 8 or pi or 172 million, that will always be the slope. Wait, start again. I just tuned in. Don't worry, we're not done yet. We're not even close to done. I still have like 5 more problems. Thank you, Amelia, for the follow. I'll let you answer that, Snorlax. I will let you answer that. Because I know where you're going. Okay, I understand it now. I think I just got confused because it wasn't a number. And that's okay. Thank you, Smiley Face, for the follow. Thank you, Dan, for the follow. No problem, Air. Happy to help. So remember that pi is a number. Pi is the number equal to about 3.14 ... Can you explain how to do cube roots in the denominator? My AP Calc teacher completely omitted that. Are you talking about rationalizing the denominator, Connor? Is there any IVT problems? I'm struggling with that. Have I done a live on IVT yet? I must have. I think so. Let me check. Let me just do a quick check. I'm pretty sure I did one of those already. And if I did, I will refer you over there. Yep, I did. So, I actually have that live up over here. So if you go here and go to this channel, you'll be able to find my live on IVT. Thank you, Connor, for the follow, and thank you, Burb, for sharing the live. Hey, Ellie, how's it going? Are you able to quickly go over how you got the numerator to negative pi, please? No using L'Hopital's rule to solve for a limit with a cube root in the denominator when you use a conjugate. What math is this? This is calculus. Thank you for sharing the live, Bones, and thank you, Heinous Crude, for the follow. Okay, so... Alright, I'm gonna answer Connor's question first, and then I'm gonna answer your question, Ellie. So here, I'm gonna write it on a note card because I want to save this space for problems. So let's say I had something like this, right? Let's say I had, I don't know, 1 over the cube root of 3x. Is that what it looks like, Connor? Or something like this? Oh, you meant numerator. So something like this. So like the cube root of some function, let's say 3x over, say, I don't know. I'm just going to put something random in here, like e to the x. You got pre-calculus? I'm actually going to be announcing a second live here soon. That's going to focus on everything before calculus. Thank you, Alejandro, for the follow. Cube root plus a constant. Sure, like plus 6. Something like that. And your question is using L'Hopital's rule to do this, yes? Alright, so e to the x can never equal 0, but let's pretend for a moment that it can. So, what I'm going to do is remember cube root of anything. So, cube root of x is equal to x to the 1/3 power. So my first thing would be to do this. I would say, okay, instead of writing the cube root of x of 3x, let's write 3x all to the 1/3 power. And then from there, I would use chain rule. Thank you, Berglund Signature, for the follow. I agree, Air. That's right. So I would change the cube root to an exponent and use power rule, which you would have to use chain rule for. But yes. Thank you, Alejandro, for the follow. I don't remember if I thanked you already, but in case I haven't, thank you. Does that answer your question, Connor? What is okay? So chain rule says that if actually I have the rule right here. So chain rule says that if I have a function trapped inside a different function, I take the derivative of the outer function, leaving the inside alone, and I multiply it by the derivative of the inside function. Thank you, Rosemary, for the follow. But yeah, does that answer your question, Connor? All right, Ellie, you are next. Are you able to quickly go over how you got the numerator to negative pi, please? Sure. So, could you explain chain rule again? I will in just one moment, Alejandro. So here, not really, but you can continue what you were teaching. Okay. If you want, DM me a photo of your problem, and I'll be able to help you there. Because sometimes it helps me to see the problem. That way I can give you so that way I can see the context. So here's how I got negative pi. So this is the unit circle. The unit circle is so with the unit circle, I have x, and I can plot my cosine and sine into a xy coordinate. So my x value is cosine and the y value is sine. So here I need to find cosine of negative 4 pi. So the unit circle, one revolution around the unit circle is equal to 2 pi. Thank you, emoji, for the follow. I can't really tell the emoji because it's tiny, but thank you. Thank you, Ginger and Christ, for the follow, and thank you, Edgardo, for the follow. Okay, can't you use a calculator? I could, but where's the fun in that? So, here, one revolution around the unit circle is 2 pi, and this negative tells me which direction I'm going. So if it's positive, I go counterclockwise, and if it's negative, then I go clockwise. Negative 4 pi is negative, so it tells me I need to go 4 pi radians clockwise. So one revolution counterclockwise is going to equal negative 2 pi. So if I did another revolution, it would give me the negative 4 pi. So here is my point, and cosine of negative 4 pi is 1. So that's where so cosine of negative 4 pi is 1. 1 times pi gives me 5. The negative comes from this 2 times negative 4, which is negative 8. So it could be, you could write it as pi over negative 8, but a lot of people write it as negative pi over 8. Does that answer your question? All right, chain rule. So, is my next exercise, doesn't the next exercise involve chain rule? It does. So, where are you? Alejandro, if you want, the next example is going to have chain rule in it, so I will explain it then. Thank you, Jason Potter, for the follow, and thank you, Aiden, for the follow. All right, so on to our next example. So here, I want to find the limit. Yeah, limit as x approaches 0 of the following. So I have sine of 2x plus 7x squared. Yeah, no problem, Alejandro. Minus 2x all over x squared times x plus 1 all squared. Actually, this is going to have two versions. This is going to have two chain rules in it, so that's even better. Sorry, I have to refocus my camera there for a moment. There we go. Okay, so here we go. So let's plug in 0. So, and let's see what I get. So I have 0 minus, so up top, I have sine of 2 times 0. Well, 2 times 0 is 0. And sine of 0, well, here's 0, and sine is the y value, so the sine of 0 is 0. So this is going to lead us 0 plus 0 times anything is 0, so this is 0 plus 0 minus 0 gives me 0. And on the bottom, I have 0 times anything is 0, so this gives me 0 over 0. Because I have 0 over 0, I can use L'Hopital's rule. Are these practice problems available anywhere? So usually I get my practice problems from a few different sources. If you type in L'Hopital rule practice problems on Google, you'll be able to see a lot of them. Tonight I am using the practice problems from Paul's online notes for L'Hopital's rule. But again, that's not the only source where I get them. That's just the source I'm choosing tonight. So, can his rule be used if x approaches infinity? Yeah, absolutely. So, remember, the only condition is that this has to go to either 0 over 0 or infinity over infinity. As long as one of those two conditions are met, then you can use L'Hopital's. Absolutely, Jay, no problem. So now I'm going to take the limit as x approaches 0. I'm going to take the derivative of both the top and the bottom. Okay, so let's start with this sine of 2x. So here, instead of taking the derivative of sine of 2x, I want to find the derivative of sine of bottle cap. What's the derivative of sine of bottle cap? Alejandro says cosine. Yeah, that's absolutely right, Alejandro. That's right, Alexander. So it's going to be cosine. That's right, Eunice. That's right, Jay. It's going to be cosine of bottle cap. So here's how chain rule works. Chain rule says if I have a function trapped inside another function, I take the derivative of the outer function and leave the inside alone, and then I take the derivative of the inner function. So here I have cosine of whatever's underneath my bottle cap. What's underneath my bottle cap? It's 2x. And then I need to multiply by the derivative of the inside. So the derivative of 2x is 2. So the derivative of sine of 2x is 2 times cosine of 2x. I agree, Mel. It is nice. So here, what is the derivative of 7x squared? Actually, there's another rule that we're going to have to use later. Eunice says 14. Alexander says 14. Eunice said 14x. Excuse me. Alexander says 14x. Can 2x be placed to the left with 2 and make it 4x? And if not, why? So that is a good question. The answer is no. Why? Because I'm not multiplying 2 by 2x. I'm multiplying 2 by cosine of 2x. So cosine of 2x is not cosine times 2x. It's cosine. This is a separate function. So I can't just multiply the 2 and the 2x. Logan says 14x. Jay says 14x. Sebastian, almost there. Remember, take your exponent and multiply it by this. So it's not 7x, it's 14x. Do I predominantly do calculus lives? For now, yep. But soon, I'm going to be going into other topics. And then the derivative of negative 2x, remember, a variable without an exponent is the same as the variable raised to the first. You're exactly right, Jay. It's going to be negative 2. You're exactly right, Toxic. Yeah, you got it right. Way to go, Jay. Way to go. And wait, I missed where the 2 in front of cosine 2x came from. No problem. So we did what's called chain rule. So chain rule, this 2x is trapped inside the sine function. Thank you, Andre, for the follow. So in order to take its derivative, I have to take the derivative of the outside. Thank you, Logan, for the follow. Take the derivative of the outside. Thank you, Toxic, for the follow. And then leave the inside alone. So derivative of sine is cosine, leaving the inside alone. And then I take the derivative of the inside. So the derivative of 2x is 2. So that's where that 2 came from. Thank you, Sebastian, for the follow. To simplify L'Hopital's rule, can you just place the derivative of the number within the parentheses to the left? I need to read that question one more time just to make sure I understand it. To simplify L'Hopital's rule, can you just place the derivative of the number within the parentheses to the left? Sometimes, like here, if I were to have a squared in here, then the derivative of the outside is let me try it again. The derivative of the inside is always going to be multiplied by the derivative of the outside. What would you do to the bottom? Would you do product rule and then leave the top over the result? Yep, that's exactly what we're going to do. We are going to do product rule here. So let's do product rule. So product rule says that if I have a function times another function, its derivative is going to equal the derivative of the first function, multiply, and we leave the second function alone to be multiplied by that. And then we switch the dance partners around and take the derivative of the second function, multiply it by a first, and add them together. Question, why did you change from sine to cosine? Cosine is the derivative of sine. That's right, Jason. Is there an easy way to remember product rule? There is a chant. This is what I use. So because I use G and J here, I say G prime J plus J prime G. Thank you, Yang, for the follow. Thank you, the one and only, for sharing the live. Thank you, Moo Rocking, for the follow. Just reminded me I need to do my AP Calc homework. Thank you. No problem. Glad I could remind you. All right. What do you mean? Like how? Like multiplying it out and doing power rule, but you can't do that unless it what? Well, you could simplify this. You could FOIL x plus 1 all squared and then distribute the x squared. But rather than doing that, no problem, Alejandro. Thank you for joining us. Have a good night. Thank you, Perry. OMG, you just learned this tonight. Perfect timing. So, here, I'm going to take, this is my first function times my second function. I'm in BC Calc and on Unit 1.4. I'm struggling even on basics, taking so long to understand. I'm sorry to hear that. I just feel like product rule would be easier with that term. I agree. That's why we're going to use product rule. Hey, June, how's it going? So here, I'm going to let g of x equal x squared and j of x equal x plus 1 all squared. And then obviously using chain rule. Yep, that's exactly what we're gonna do. You're in Calc 7 or something. Interesting. Calc 7. Can you start at 2 plus 5 and then work our way up to college? That would take... How long would that take me? That would be... what? That would take me a few years. If I did a live every single day... Oh, you're in a PhD course. That's awesome. Congratulations. I never made it past my bachelor's. Yes, we are going to use product rule down bottom. It's okay, you got time. I'm so rusty on Calc 2. I'm sorry to hear that. Well, I'll be doing Calc. I'm actually starting lives on Calc 2 in about 2 weeks. Thank you, June, for the follow. All right, so I feel like I have like 8 questions I need to answer. Hey, Daniel, how's it going? Have a good night, June. Thank you, PYL Math Tutoring, for the follow. Let's see if you're right. Thank you, DJ, for the follow. Okay, so back to this. So G prime of X and J prime of X. When you finish this problem, can I ask for help on a question? So tonight I'm gonna focus on L'Hopital's rule. If it's that, sure. If not, feel free to give me a DM and I'll help you on a question there. All right. Right, so that's right, Alexander. So the derivative of x squared is 2x. And then I need to use chain rule to find the derivative of x plus 1 all squared. So instead of x plus 1 all squared, I'm just going to use bottle cap squared. And yes, I have like a ton of bottle caps in here. So of course I'm going to use them as a prop. So here, I want to find the derivative of bottle cap squared. Product rule is simple in this case, but if I can avoid chain rule, then I will do it. Fair enough. And sometimes, though, you won't be able to avoid chain rule, so it's good to know how to do it anyway. But yeah, you could, like I said, you could FOIL that and then distribute, and it will get you the same answer. But I prefer doing as little work as possible. So yeah, so here, bottle cap squared's derivative is 2 times bottle cap. So that's going to be 2 times what's underneath my bottle cap is x plus 1. And then I multiply by the derivative of the inside. So the derivative of x is 1, and the derivative of 1 is 0. So this is 1 plus 0, which is 1. 2 times 1 is 2. So, did you get that right? You did indeed, Angelic. Very good. So now, I'm going to link my functions together. And so remember, g prime j, so this is going to be 2x times x plus 1 all squared, plus j prime g. So this is going to be x squared, 2x squared, times x plus 1. Thank you, Angelic Sway, for the follow. So from here, what I could do is I could factor out a 2x times x plus 1. Is it necessary? Not really. I'm going to do it anyway. So limit as x approaches 0. On top I have 2. And actually I could factor out a 2 there too. So I have 2 times cosine 2x plus 7x minus 1 all over 2x times x plus 1. And that would leave me with what? That would leave me with x plus 1 plus x. I think that's right. 2x divided by 2x is 1. x plus 1 all squared divided by x plus 1 is x plus 1. And then 2x squared divided by 2x is x. And then x plus 1 divided by x plus 1 is 1. Oh, so this should be 1, not x. Right? Yeah. Cool. So, I have 2 in the numerator multiplied by everything and 2 in the denominator divided by everything. So I could say bye to that. Could you also solve this by considering degrees? If this were infinity, absolutely. So what am I left with? I'm left with the limit as x approaches 0 of cosine 2x plus 7x plus 1 minus 1, all over x times x plus 1 times x plus 1 plus 1, which is x plus 2. No, I was right. The x was right. You're right. So this would be 2x plus 1. 2x plus 1. See, even I doubt myself from time to time. So now, all I'm going to do... Thank you, Gustavo, for correcting me, or confirming that my first answer was correct. So now what I'm going to do is I'm going to plug in 0 everywhere I see an x, and let's see what happens. So I have, this is going to be cosine of 2 times 0 plus 7 times 0 minus 1 all over... Where did I go wrong? So this would be 0 times 0, 0 times 1 times 1. And 0 times anything is 0. You forgot to cancel out the x plus 1 when you factored it out. Here? I'm not sure where I could cancel that out. Oh. No, that wouldn't work. Thank you, Thaki, and thank you, Wave, for the follows. How many rules should we know for derivatives? I have 21. Most of them are... This one? Oh! You know what? You're right. No. Here, I could factor out a 2x, right? Thank you, Jay, for the follow. Let's see, where did I make that mistake? I did the product rule right, I think. X squared is 2x. X plus 1 all squared is 2 times x plus 1. Thank you to Bratwurst for the follow. Couldn't you take L'Hopital's rule? I could, except that I end up with negative 1 over 0. And that's the goal. I wanted this to be 0. Yeah, no problem, Hayden. No problem at all. Thank you, Apple user, for the follow. So as you can see, sometimes I make mistakes too. So let's see. This and this. X squared times 2 times x plus 1. Oh, I wonder. No, that wouldn't make sense. Thank you, Tim, for the follow. So what's going through my mind right now is this. I end up here and factoring the bottom. Thank you, Ted, for the follow. You're right. That's what I'm wondering. So the top derivative is right. The bottom derivative is wrong somehow. So let's go back here for a moment. Let's cancel this for a moment. Where did I go wrong? Oh, I see what they did. Okay. So let's do this. Instead of I lost an X. I shouldn't have though. Okay, let's try this. So I'm gonna go back here for a moment. So derivative of first times the second, so that's gonna be 2x squared times x plus 1. That's right. And I have 2x times x plus 1 all squared. That's right. Well, if I end up with negative 1 over 0, I can't take another derivative because I don't have 0 over 0. Now, if I were to so if I refactor that, so the problem started up here. This is the original problem. I'm trying to figure out where I went wrong here. I did, so that would leave me with just x. Split it. How would I split it? Like split the fraction? That's right. You're exactly right on that. Because if you do 2 cosine of 2, you're right. You think we oversimplified it. Okay, let's do this. Let's not worry about simplifying. Let's instead just plug in 0. So I get 2 times cosine of 2 times 0 plus 14 times 0 plus 2. Oh. Nope. I found the mistake. I said cosine of 0 was 0. It's 1. Yeah, there's a mistake. 2 times 0 times 0 plus 1 all squared plus 2 times 0 squared. Yeah, there it is. 0 plus 1. Cosine of 0 is not 0, it's 1. 1. Yep. 2 times 1 is 1. 2 times 1 is 1. 2 times 1 is 1. Let's try it again. 2 times 1 is. Oh, this should be minus, not plus. So that's 2 plus 0 minus 2 over anything times 0 is 0. So that's 0. 2 minus 2 equals 0 over 0. There we go. There we go. You're right. It is still 0 over 0. So that means I can do L'Hopital's again. So now I have limit as x approaches 0 of the following. So I have what was the problem before? Here's our original problem. And now we're here. Now we are here. Now we're here. So I need to take the derivative of both the top and the bottom again. Oh, you meant the mistake before. So, turns out the math I did was, I think, correct. I just said that cosine of 2 times 0, cosine of 0 was 0 and not 1. That's why I was running into negative 1 over 0. I think the simplification was still right. But, yeah. Anyway, is this Calc 1? It is indeed. So, derivative of cosine 2 times cosine of 2x. It's alright, we all make mistakes, especially with trig coming from an absolutely. I 100% agree. We all make mistakes, and that's okay. The important thing is that we learn from those mistakes, yes? So now, we want to find the derivative of cosine of 2x. So, instead of finding the derivative of cosine of 2x, let's find the derivative of cosine of bottle cap. What is the derivative of cosine of bottle cap? I have my first test from Calc 2 tomorrow, a little scared. I'm sure you're going to do fine, Gustavo. What's it on? Eunice says 2 sine a bottle cap, negative 2 sine a bottle cap, excuse me. Jason says negative 2 sine, yeah. So the derivative of 2 times cosine of bottle cap is negative 2 times sine of bottle cap. What's the bottle cap? What's underneath the bottle cap? It's 2x. Why is that? Because the derivative of cosine is equal to negative sine. Thank you, Sarah, for the follow. So, now, thank you, Christian, for the follow. So, and thank you, Jason, for the follow. So now I need to take the derivative of what was underneath the bottle cap. Can you do chain rule, please? I actually already did a live on chain rule. You can find it here. You got 100% for the first time on a calc exam, Christian? That's awesome! Congratulations! Way to go! Way to go, Christian. I'm proud of you. Thank you, Gustavo, for the follow. In cybersecurity, they are math. Yep, there's math in cybersecurity. In fact, actually, let me finish this problem, and then I'll tell you that story. So, now I need to take the derivative of 2x. So the derivative of 2x is going to be what? You're right, Jay. It's going to be 2. That's right, Christian. This is going to be, that's right, TT. It's going to be 2. And then, that's right, Tori. And then what's the derivative of 14x? Christian says 14. Olivia says 14. Jay says 14. Yeah. So it would be plus 14. Yo, try and help me with a trig substitution problem. Are we talking about integration, Sergeant? Okay. So, if you want, I'm focusing on L'Hopital tonight, but if you want, feel free to send me a picture of the problem, and I will give it a look. And then yeah, so the derivative of negative 2, that's right, Christian, it's going to be 0. Why? Because the derivative of a constant is equal to 0. Yeah, no problem. No problem at all. And then on the bottom, have a good night, Tim. How's it? Have a great rest of your evening. So now, what I'm going to do is this. I'm going to do product rule on both of these. So I'm going to need a longer fraction bar to write this. So my first function, so I'm going to write this over here. So g of x is equal to 2x, and j of x is equal to x plus 1 all squared. X plus 1 all squared. What was your favorite math class you ever took? So there's this one class in college I took. It was called Modern Algebra. Some of you might know it as Abstract Algebra. That was probably my favorite class. Thank you, Tori, for the goat, and thank you for the you're awesome, Tori. Intergalactic integration. I'm not sure I've ever heard of that one. Have a good night, dude. Keep up the work. Very wholesome. I'm gonna study a little before bed. Night, y'all. Good night, Gustavo. Have a great rest of your evening. Thank you for that. So now you're actually making this fun to watch. I very much appreciate it. Thank you, Christian. I'm happy to hear that. Thank you, Haza, for sharing the live. And Christian, that's always my goal. I want to try and make math, if not entertaining, at least a little more bearable for everyone. So yeah, so I want to take the derivative of 2x. So remember, a variable without an exponent is the same as that variable raised to the first. So thank you, Omizon Mechanical Equipment for the follow. That's right, Christian. It's going to be 2. That is absolutely right. I'm here to get exposure on what's to come later on, and I'm so happy I even grasped some of the concepts I made. Thank you, Jay. Thank you so much. I really appreciate that. Do I teach differential equations too? I do, Angel. Yeah, you're right. You're right, Christian. I know what you meant. Yeah, that's absolutely right. It would need chain rule. So, what I'm going to do is we've already done this derivative. So I'm going to go ahead and just copy what I've done over here. Over here. This is going to be 2 times x plus 1. Are you a HS teacher or professor? I used to teach high school. I don't anymore. I found that the classroom wasn't for me, and that's okay. Yeah, I did. I used to teach, but not. I haven't taught in the classroom in. It'll be 8 years next year. Nope, not at all. Not at all. Even if it was, I wouldn't tell you. So yeah, now I'm done half of the half of this problem. So now I'm gonna move on to the other half. So I'm gonna have another G and J. So actually, before I do that, I'll go ahead and do the first set of product rules. So I'm gonna link my two functions together. So I have two. So I have G prime J. So that's gonna be 2 times x plus 1 all squared plus J prime. So that's going to be plus 2x times 2. So 2x times 2 is 4x times x plus 1. Hey, period, how's it going? It has been a minute. How have you been? I taught high school math 27 years. Not the easiest thing in the world to do, Lowell. I agree. I fully agree. Yeah, it has been a minute, period. I'm really hoping the content works out for you coming from a fellow content creator, a CS major. Good to know. That is actually really good to know. Doing well, just lots of studying and work. How are you? I'm doing good. And thank you, Christian, for that. I hope it works out too. So now I have 2x squared times x plus 1. So I'm going to do product rule again. So I'm going to let g of x be 2x squared. I'm going to write my g prime here. I'm going to let my j of x equal x plus 1. And I'm going to write my j prime here. What should I fill in for g prime of x and for j prime of x? Eunice says 4x and 1. Christian says 4x. Dollar says Christian as the second half says 1. This type of math has no value in real life. I disagree. I 100% disagree. There are actually several very practical uses for calculus. Just because we don't see it every day doesn't mean that it's not useful. Yeah, so 4x would be the derivative of 2x squared, and the derivative of x plus 1 would be 1. That's right, everyone. Great job. So now I'm going to link my functions together. So here, plus g prime j, so that's going to be 4x, 4x times x plus 1, and I'm going to run out of space. Or maybe not, because 2x squared times 1 just gives me 2x squared. Why not use L'Hopital's? We are. We are definitely using L'Hopital's. So now, rather, as we learned from the last time, I'm not going to mess around with this. Instead, I'm just going to plug in 0 and see what I get. So it's going to be negative 2 times the sine of 2 times 0 times 2 plus 14 all over 2 times 0 plus 1 all squared. I can actually combine those like terms. So 4x times x plus 1 plus 4x times x plus 1 gives me plus 8 times 0 times 0 plus 1 plus 2 times 0 squared. All right, so we learned earlier that, so 2 times 0 is 0. What is sine of 0? Sine of 0 is the y-coordinate of when we have 0 radians. So sine of 0 is 0. So I have 0 times negative 2 times 2. Well, that's going to be 0. So I'm left with 14 up there. Do you plan to do Calc 3 topics at any point? So if my math is correct, I'm going to start Calc 2 here in the next couple weeks. I think I'm probably getting to Calc 3, I would guess sometime either late November or early December. Yeah, no problem, Christian. Let's watch the language, though, please. So then I have 2 times 0 plus 1 squared, all squared. 0 plus 1 is 1. 1 squared is 1. 2 times 1 is 2. 8, anything times 0 is 0. So this is 8 times 0, which is 0. This whole thing becomes 0. 0 squared is 0. That becomes 0. 2 plus 0 is 2. And 14 divided by 2, as you said, Jay, is 7. So that is my answer. Awesome. So yeah. Yes, we did do it, finally. Can you do a problem for limit approaching infinity? I can, Rice. I can indeed. Let's see if we can't get the 6K likes, though. Let's do a quick math tap. There are 36 of you in here. I'm more than sure it'll be less than if everyone in here did a quick mad tap, we'll get to 6K in no time. While I do that, I'm going to go ahead and turn the page. So we'll do a couple more problems, and then we will call it a night. Thank you, Phantom, for the follow. So yeah, hopefully, thank you, Rice Buckets, for the follow. Hopefully everyone's having a great Tuesday or night. Thank you, Gorilla, and thank you, Nadine, for the follows. Thank you all for the likes. I think we can get to 6K here in no time. But yeah, so It is Wednesday morning over here on the East Coast, but I hope everyone had a great Tuesday afternoon, or Tuesday overall. So yeah, I mean, I had a pretty good Tuesday, I think. We are almost to 6K. I know you all got this. We're less than 500 away. You're all doing such a great job. You had a great Tuesday, Mathematic Fanatic? That's awesome. That is really cool. I had a tutoring session today, but they ended up canceling. Um, so I didn't do any. So this is my first um tutoring that I've done today, but that's okay. Oh, perfect. We're already at over 6K. Let's go. Thank you so much, everyone. All right. So Rice, you asked for a problem for a limited approaching infinity. We will go ahead and do that. So limit as x approaches infinity of the natural log of 3x all over x squared. The four, yes, I had 4 tutoring sessions today and 3 of them canceled. The 4th one was a new student and it went great. That's awesome. Way to go. That's really cool. That is really cool. So, let's go ahead and see what happens when I plug in infinity. Well, 3 times infinity is going to be infinity. The natural log of infinity is infinity. And infinity squared gives me infinity. So I have infinity over infinity. I think it's time to get the second water. There we go. Anyway, now, since I have infinity over infinity, 0 over 0 is not the only time in which we can use L'Hopital. We can also use it if we end up with infinity over infinity. So here, what I'm going to do, because I have indeterminate form, I can actually take the derivative of the top and bottom and try my limits again. So I have limit as x approaches infinity of, well, what's the derivative of the natural log? So instead of having the derivative of natural log of 3x, let's find the derivative of the natural log of bottle cap. Unit says 1 over bottle cap. Would the ln be 3 over x? No, not quite, Bones. So the derivative of natural log of bottle cap is 1 over what's underneath my bottle cap. And what's underneath my bottle cap? It's 3x. So I have 3x. And because I had to use the bottle cap, I now need to find the derivative of what was underneath the bottle cap. So the derivative of 3x is going to be 3. And to simplify, let's do this here. Limit x approaches infinity of 3 over 3x over, what's the derivative of x squared? What is the derivative of x squared? Rice says 2x, Nadine says 2x, Gorilla says 2x, Jay says 2x. Yeah, that's right. Take the power, move it out front, and subtract 1 from the exponent. So I have 2. X there, 2 minus 1 is 1. That's right, Roger. It's 2x. So now, it's going to be over 2x. Now, I have a 3 in the numerator and a 3 in the denominator, and I'm multiplying. So we can say bye to those 3's. And I'm left with limit as x approaches infinity of 1 over x divided by 2x. Now, before I take this limit, I'm going to go ahead and simplify this a little bit. So do we agree or disagree but I can write 2x as 2x over 1. Oh, period would also like to be on the record of saying 2x. Duly noted, period. That is the right answer. Jay says, I supremely agree. Roger agrees. Zeno says yes. Cool. That's right, Rice. That is exactly where I'm going. So I'm going to KFC. I'm going to keep the 1 over x. 1 over x. Change the division to a multiplication problem. Kind of funky how the 3 disappeared. Absolutely agree. And then I'm going to flip 2x. So I have 1 over 2x. Limit goes to 0. No, it doesn't. In this problem, it goes to infinity. So here, I have 1 time. So limit as x approaches infinity. What would be the answer to this multiplication problem down here? One over 2x squared, says Jay. Nadim says 1 over 2x squared. Rice says 1 over 2x squared. Oh, you meant it converges to 0. Yes, we're going to get there in a moment. Roger says 1 over 2x squared. That's okay. Yeah. So 1 times 1 is 1. And 2x times x gives me 2x squared. So instead of taking the limit of this, now we're taking the limit of 1 over 2x squared. And as Yohomi mentioned earlier, this is going to converge to 0. Here's why. So when we take the limit as x approaches infinity of a fraction, I'm gonna notice what's going on. So 1 is not growing. 2 times it. So at infinity, it doesn't really matter whether I'm multiplying infinity by 2 or not. So I'm looking at this as 1 over infinity. So this is going to converge into 1 over infinity. No, it's going to, yeah. So imagine taking one slice out of a pie or a cake or a pizza or whatever you like, one piece out of infinitely many. It might as well be 0. So that's why our answer is 0. Kind of cool, isn't it? I think it is. Absolutely. Absolutely, Rice, because it is such a small number. Remember that if my denominator is large, that means the whole fraction is tiny. The way I understand it is that because a constant is very, very small to infinity, it goes to 0. Right. Could you do one that has trig like cosine or sine? I always get confused on those complicated questions. Let me see if I have another one of those. I think we did 2 of them already, but let me see if I can find another one. I think this will be a final problem anyway. Hmm. Hmm. How'd I get the natural log over x? Where? Here? I think it's fun to guess which function will win in f of x or over g of x because before working it out. Absolutely. Oh my OMG, I'm learning this right now. Perfect timing, Andrew. Yes? Okay. So we got this because that's the problem we were given. This is the problem we started with. So I can't find another one. Oh, you meant one over here. Whenever you plug in infinity that's on the numerator side of a thing, it automatically becomes infinity. As long as there's more x's than in the numerator than in the denominator. Okay, so that's the result of chain rule. So the derivative of natural log is 1 over x. So, but I have 3x. So I take the derivative of the outside function, leaving the inside alone. So that's 1 over 3x. And then I multiply by the derivative of the inside. Right, that's right. That is absolutely right, Roger. Perfect. All right, so I couldn't find one with a oh, I stand corrected. I stand corrected. I did find one. We'll make this the final problem of the evening. So, there are 35 of us in here right now. Let's say to get to the final problem, let's see if we can't get to 8K likes. Let's go ahead and do one more quick mad tap to 8K. When will prepare calculus start? Pre-calc? Thank you, pizza is good for the follow. I do agree with that. I 100% agree with that fact. I talk about pre-calc one. Thank you, Gramps, and thank you, homie, for the follow. Pre-calculus, yeah, tomorrow. So I'm actually right now this live. So I'm going to be announcing a second live by around the end of the week, and that will have your pre-calculus, your algebra, and your geometry. But we're gonna be finishing. We're gonna be finishing up calculus 1 here soon. I have to look at the analytics and see. Do you touch on Calc 2? I do. In fact, we're going to be starting. So I'm finishing Calc 1 sometime in the next 2 weeks, and we're going to start Calc 2 out as soon as we're done Calc 1. Oh, we're already past K. I just noticed that. Sorry, everyone. All in one because I really need it since I have a 57% in my class. So I can start pre-calc in that live. Thank you, Juan, for the follow. Cool. All right. So I told you we would start it at 8K, and I will do that. So limit as x approaches 6 of the following. So I'm going to have sine of pi x divided by the natural log of x minus 5. I happen to come across this live, and I have to say kudos to you and everyone here learning. Thank you, Not So Physical Hobbies. Thank you so much for that. I'm glad that you were able to stay and join us tonight. Thank you, Jolly, for the follow. That's right, yo homie. That's absolutely right. So here's why. So if I plug in 6 for x, I get sine of 6 pi over the natural log of 6 minus 5. So sine of 6 pi, if we look at our unit circle, if 1 revolution around the unit circle is 2 pi, then 3 revolutions will be 6 pi, and it will lead me to the same place. So the sine, remember the sine is the y value. So sine of 2 pi is the same as the sine of 4 pi, which is the same as the sine of 6 pi, which is 0. So sine of 6x is going to be 0. And the natural log of 6 minus 5, that's the natural log of 1. Natural log of 1 is 0. So now, because I add 0 over 0, I can use L'Hopital's rule. Yes. So, can you do a continuity problem before you end the live? So I actually did a live on continuity, and you can find it right here. But if you want, I can yeah, no problem. If you want, though, feel free to feel free to send me a photo of the problem, and I will go ahead and work on it. All right, back to this. So, what is the derivative of sine of bottle cap? Right. You're right, Eunice. It would be cosine of bottle cap. What's underneath the bottle cap? It's pi x. This is going to be pi x times the derivative of pi x. So derivative of pi x is going to be pi, right, times pi divided by the natural log of x minus 5. So I'm going to use natural log of bottle cap. That's okay. Pick up the ball and keep moving. Don't let the defense grab it before you. Nadine says 1 over bottle cap. Eunice says 1 over bottle cap. Gorilla says 1 over 5x. Nadine says 1 over... Jay says 1 over bottle cap. Nadine says 1 over x star star star. So the derivative is going to be 1 over my bottle cap, which is x minus 5, times the derivative of x minus 5. What's the derivative of x minus 5? It would just be what? Thank you, Eunice. Thank you, Nadine. That's exactly right. The derivative is 1. So 1 times 1 over x minus 5 is 1 over x minus 5. So now, here's what we're going to do. I'm going to go ahead and plug in 6 now, and let's see what I get. So I have cosine, or pi, times cosine of 6 pi, all over 1 divided by 6 minus 5. So, cosine of 6 pi, remember cosine is the x value. So if I do 3 revolution, if 1 revolution is 2 pi, then 3 revolutions will be 6 pi. What is the x value at this point? Eunice says 1, Nadine says 1. Right. So this is going to be 1 times pi. 1 times pi gives me pi. And then I'm going to divide that by what? So 1 over 6 minus 5. 6 minus 5 is 1. 1 divided by 1 is 1. So I have pi over 1. So my final answer is... That's right, Nadine. It's going to be pi. That's right, Jay. And with that, we are going to go ahead and call it an evening. Sorry about that. Thank you all for joining me tonight. I really do appreciate it. But before you go, I don't think so, Yohomi. I don't think it's too late at all. Can you define derivative and plug it into how x minus 5's derivative is equal to 1? Sure. So the derivative tells the story of the slope. So, the derivative tells us the slope of a function at a single point. So, I can rewrite x minus 5 as... So we understand the term y equals mx plus b, yes? Do we agree with that, Easton? Yeah. So would we agree that I could also write it as y equals x plus 5? Or x minus 5? Yeah. So if the derivative tells us the slope, then the derivative of mx plus b is just the slope, which is m. So that's why, and since I have no number being multiplied by x, we assume that there's a 1 being multiplied by x. So that's the reason why the derivative of x minus 5 is equal to 1. Yeah, you're most certainly welcome, Jay. Always happy to help. All right, so with that, I'm going to go ahead and call it a night. But before I go, I need to plug a few things. So first, you can follow me. Okay, thank you. What math is this? Anyone? This is calculus. So, you can follow me here at this channel. And here is the set of all the things that you should do when you get to my channel over there. You're awesome. Thank you. You're most certainly welcome, Nadine. Thank you so much for that. Thank you for your help. I have lecture in the morning. I will definitely follow. Thank you, Humberto. Where do I be live more? So I'm usually live here on TikTok. If I'm going to major in electrical engineering, how important is this that I get this down? Absolutely. Absolutely. Engineering does require calculus. Thank you, Umberto, for the follow. As a tutor of economics/English at my college, math has always scared me, so thank you so much, and we'll tune in when I can. You are good. Thank you, Jay. I really appreciate that. And then, if you want to follow me on TikTok, here is where you can follow me. And as you can see, I made it kind of look like an integral. So I thought that was kind of funny. And then there are a couple other people that I highly recommend that you follow here on TikTok. So first is ACG Math Tutoring. So she does really good work with the people getting ready for the ASVAB, the AccuPlacer, their GED, their TEAS test. Thank you, Easton, for the follow. And even if you need a refresher in algebra and geometry, I would highly recommend that you go to ACG Math Tutoring. Audrey is actually the one who convinced me to join TikTok after a while of going back and forth. So if it weren't for her, I wouldn't be here right now. Thank you, Easton, for the follow. And then I also recommend you follow Learning with Lynette. I believe she's live right now. So as soon as I am done, that is where I am headed. So she does a really good job with the abacus. She explains it really well. Yes, she is live right now. So yeah, as soon as I'm done, I'm going to go ahead and jump into her live. And if you do jump into her live, go ahead and tell her I sent you. And then, on the flip side, I offer online math tutoring. So I offer tutoring in both groups and one-on-one. So for group tutoring, I do group tutoring for groups of 3 to 10 students per group who are all taking the same course at the same time. Now, that doesn't mean that you have to be taking it with the same teacher or even at the same school. It just means that you have to be taking the same class. So let's say you and 5 of your friends are all taking Algebra 2. If you wanted group tutoring, because you're all taking it now, you can definitely sign up. And for that, I charge $35 per hour per person for this school year. For the 25-26 school year. And then I also offer one-on-one tutoring, and my rates for that vary depending on how often you need tutoring and how often you want to meet per week. And here is a list of everything that I currently tutor. So I tutor Algebra 1 and 2, Geometry, Pre-Calc, Regular and AP, Regular and AP Stats, all 3 Calc classes, both AP Calc classes, Differential Equations, and Linear Algebra. I had a question for me as pre-nursing. Do I only need Math 126 EE? What is Math 126 EE? I'm not necessarily sure what that is. It's pre-calculus. Okay. I'm not as familiar with pre-nursing. Thank you, Sobi, for the follow. And thank you, Easton, for the follow. Fun, quick question, if you can. What's your favorite Desmos graph to plug in for entertaining graphs? If you can't remember, it's okay. I know you... Yeah, no problem. I've been trying to recreate the Batman graph. It's a complicated function, but when you plug it into Desmos, it literally looks like the bat symbol. That one's always kind of cool. And I know it's like a decade old at this point, but it's still really fun. As long as you tell him you're never going to give him up. That's funny. Hi, Isa. How's it going? All right. So with that, I'm going to go ahead and call it a night. I'm going to also go ahead and jump into Lynette's live. So if you are all interested, feel free to jump in with me. And if I see you there, say hi. And if not, have a great rest of your night, everyone. And I will see you all tomorrow at 11:30. Bye, everyone.